This time, we will test the hypothesis using the critical value method. In the critical value method, it is about determining the critical mean value required for Z to be in the rejection region and uses it to test the hypothesis. With the critical value method, we will identify the critical value. This critical value is the parameter or the boundary that separates the non-rejection region and the rejection region. So let us use the example that we had in our previous video. A survey of CPAs across the US found that the average net income for sole proprietor CPAs is $74,914. With that, our null hypothesis is that mean is equal to $74,914. And our alternative hypothesis would challenge that null hypothesis. And so our alternative hypothesis is that the mean is not equal to $74,914. The next step is to conduct the test and to set the value of alpha. So let us say that the value of alpha is 0.05, which has a z-score of 1.96 in the two-tailed test. And our decision rule is that if the data gathered produce a z-value greater than 1.96 or less than negative 1.96, the test statistic is in one of the rejection zones. The next step is to conduct the test by gathering and analyzing the data. And the data that we have so far is that the sample mean is $78,695. The population mean is $74,914. Population standard deviation, which is $14,530, and the sample of 112. We will be using the z-score formula in order to determine the critical value. And with the formula of z is equal to sample mean minus population mean all over population standard deviation over the square root of n, we have the observed value that is 2.75. So basing from this alone, comparing the 2.75 to our critical value that is 1.96, we now know that since 2.75 is greater than 1.96, the statistical action that we will take is to reject the null hypothesis because the observed value falls beyond and outside the non-rejection area as defined by our critical value. So you will notice here that the critical value method and the z-score method is basically the same. Except for the critical method, we will include the estimation for population mean so that we will be able to identify what exactly is the value found in the 1.96 standard deviations away from the mean. And so recalling from our previous lecture, the formula for estimating the mean is population mean plus minus z-score multiplied by the standard deviation over the square root of n. Now let us plug in the different values into the formula. 74,914 plus minus 1.96 multiplied by 14,530 over the square root of 112. Notice here that we use 74,914 instead of the 78,695. This is because the estimation for population mean formula requires that we use the population mean and not the sample mean. So later on, we will want to find out if the sample mean fits into the interval as defined by these different values that we currently have. And computing for the interval, we now have 74,914 plus minus 2,690.993564, and it gives us the two answers or two parameters in the distribution, which is 72,223.0064 is less than or equal to the population mean is less than or equal to 77,604.9936. And since the sample mean that is 78,695 is greater than the upper boundary, which is 77,605, then we reject the null hypothesis.